In today's class, we will be continuing with the topic measurement. And what we're going to do is various examples with parameters and the areas of a bunch of different shapes, whether it be plane shapes, irregular shapes, and all of the such, right? So we have number one on the board. This is a triangle. It has 3 given sides. So we know to work out the parameter of this, we will have to add up all the sides. So the parameter is the distance around, which will be 10.8, add 4.3, add 12.3, right? Giving us an answer of 27.4 units. Sorry, this is millimeters. If we go on to number 2, yeah, we come back to the area. If we go on to number 2, the parameter of this again, add up the shapes, add the sides, 12.3 plus 20.5 plus 16.4 is equal to 12.3, add 20.5, add 16.4, 49.2, and this one will be units because we had no measurement given, no length. So for the area of a triangle, we have 3 formulas that we can use. The first one, the first area will be when we have a base and a height, and that will be base by height over 2. The second formula is when we have 3 sides, for example, here. When we have 3 given sides, we don't have a base, we don't have a height, etc. So area 2 will be using the 3 sides of the triangle, and the formula will be the square root of S by S minus A, S minus B by S minus C, where S is the semi-parameter. So we know what is parameter, right? Parameter is this. So semi-parameter is parameter divided by 2, like semicircle, circle divided by 2. That will be our semi-parameter, parameter divided by 2. And A, B, and C are the 3 sides of the triangle. So that's area 1. That second formula for area is that, right? And the third formula for area is, area 3 is when you have 2 sides and an angle in between. So that will be a half by AB sine C. So AB are 2 sides of triangle, and C is the angle in between A and B. Right, so we could work out the area of a triangle based on any one that we have. Once we have a base and a height, we could use 1. Once we have the 3 sides, we can use 2. Once we have 2 sides and an angle in between, we can use 3. So according to that, for example 1, or for question 1, we worked out the parameter. Now to work out the area, we can use this one because we have 3 sides given. So the first thing we need to do is go find our semi-parameter. So our semi-parameter is the parameter divided by 2. So the semi-parameter is 27.4 divided by 2. And that will give us 13.7. So that's S. So I'm going to continue on this side. And the formula is now area is equal to the square root of S minus A S minus B, S minus C, which is the square root of, what is S? 13.7 by 13.7 minus side one, any one of them, 10.8 by 13.7 minus another one, 4.3 by 13.7 minus 12.3. The order doesn't matter. And work out what's in your brackets first. So 13.7 minus 10.8 is equal to 2.9. So 13.7 by 2.9. 13.7 minus 4.3 by 9.4. 13.7 minus 12.3, 1.4, all under the square root. Keep working out below your square root, multiply them all, 1.4 by 9.4 by 2.9 by 13.7, which will give me the root of 522.85, round properly. And then the square root of that is 22.87 millimeters squared, because it's area. And that's how we work out our areas. This process is a little, tedious, because you have to make sure all is correct. But once you take your time, it's pretty easy. So that's how we work out the area of the first triangle. All right, so let's quickly run through this. We have a circle here, and they're asking us to work out several things. Firstly, the area of the triangle, we're going to use the formula a half AB sine C. All right, we're going to plug in all our information. We know that 9.8 by 9.8 is the radius. The second thing we're going to work out is the area of the minor sector. So this is the minor sector here, the small part of the circle. We know that's theta over 360 by the area of the circle. So we plug that in and we did that. Then the area of the major sector. So this is outside here. So that's going to be the 360 minus the 90, which is 270 degrees. And that's what we did with the same formula. Then we move on to the area of the minor segment. So the segment is the blue shaded part, the area between the chord and the arc. So we worked out the area of the entire sector and we subtracted from the area of the triangle to get that missing part there. So we subtract this from the sector to get our segment, and we already have that by the area of the sector minus the area of the triangle. That's what we did to get this. And we know the circumference of the circle is 2 pi r, so we will go 2 pi r to get the circumference of the circle. The length of the minor and major arc, so we know the minor arc will be here and the major arc will be all around. So the minor arc will be theta, the amount of degrees, which is still 90. So 90 over 360 by 2 pi r, which is the circumference of a circle. That's how we got this. And then for the major arc, we did the same thing, the difference, which is 270 by the circumference of the circle to get that. So that's our questions for measurement in today's class.